The law of large numbers is very important to probability theory. And the law of large numbers states that as a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability of an event. In other words, if we have more observations, that leads to better results. In other words, more accurate probabilities. If we're trying to calculate probabilities. So, for example, you could toss a coin, a fair coin, 20 times and only get 5 heads. So if you did that, you would write your probability of heads calculation as the number of times you saw that event heads occur. You saw it 5 times, and how many times was the procedure repeated? 20 times. So in other words, 1/4 of the time you saw a head, and so the probability of heads would be 1/4 based on your 20 observations. Obviously, we know, it just makes sense, that we would need to run this procedure many more times to get more accurate results. Now in this case, we know the actual probability of heads because this is a sample space that we already know something about. We know it should be 1/2. And if we then ran this procedure, say 20,000 times, this number would get very close to 1/2, if not exactly 1/2. So that just makes sense. The more observations, the more accurate your results. Now, why do we care about heads and tails on a coin? We don't. But that's something we already know the answer to, so it helps us understand the law of large numbers. Generally, we're looking at a situation where we're trying to determine the probability, and what the law of large numbers tells us is the more observations you take, the more accurate your results would be. So therefore it encourages us to get as many observations as is possible. Now, you know, an actual researcher would have limitations, monetary limitations, resources that would keep them from having an unlimited number of observations. But with this understanding, you know, you have to develop your trade-off. How much more money can you spend? How much more accurate will your results be? And you don't know what the actual probability is, like we would with flipping a coin, but you do know, because of the law of large numbers, that the closer and the more observations you take, the better and the closer you get to the actual probability of that event. So we want to apply this law to unknown probabilities. We see how it works with known probabilities. We want to apply the law to unknown probabilities. So that's what the law of large numbers shows us and helps us understand.